So for 39, I just want to expand this expression. So I want to see what is happening on the inside of this log thing. So basically, when I'm looking at this, when I say the inside, I'm looking at the 64x squared. And what I want to do is I want to think of the 64x squared as being a bunch of things combined together. And that may sound a little bit weird when I say it, but you'll see what I mean in a second. So when I say it that way, I mean, okay, well, what gives me 64, right? Is there some way that I can make 64 look like something else? And I'm particularly interested in if I could maybe get it as a value squared, or maybe if I just want to break it up into factors. So like, for example, if I was dealing with, I don't know, 15, right? 15 breaks into 5 and 3. So when I look at 64, I think, okay, well, what does 64 break down into? Last time I remember checking, it was 8 times 8. So I could rewrite this instead of as 64 as 8 squared. And then I've got this x squared value here. Well, this x squared is also like itself squared, which sounds silly, but I'll write it in parentheses like this, right? So if I have a squared value and a squared value, I could rewrite this as 8x squared like that. Now, if I chose to rewrite my log like this is one way of solving it. You don't have to solve it this way, but this is probably the way that I would think about it. Is I'd look at this and I'd rewrite it, and it's going to be log base 8 of, now here's where I'm going to write my 8x squared. With this 8x squared here, what this 2 as an exponent means is I can take this and bring it out in front of my log thing. So this is going to be equal to 2 times, you don't really need to put the over-exaggerated multiplication sign, but is what it is. And then this is now going to be log base 8 of 8x. So that's my exponent rule, my power here for my logs. Then I look at this and say, okay, well, what is happening on the inside here? What's happening is I have 8 times x. If I have multiplication, that's addition with my logs. So when I look at this thing, I'm saying, okay, this is going to break down into 2 on the outside. I'm going to put a big set of parentheses. Actually, I'll change the color here. Put a big bracket here for this thing here, which is now going to break into log base 8 of 8 plus log base 8 of x. Does that make sense?
Mm-hmm.
So then from here, what I'm saying is, okay, well, just keep in mind we have a distributive property, but what is log base 8 of 8? Log base 8 of 8 is just 1. So right now I'm going to simplify this thing, do it green here. So now I have 2 times 1 plus, and now here's just log base 8 of x. There's not really much I can do. That didn't come out to be a very good plus sign. Log base 2, there we go. So now as I look at this, I'm saying, okay, well, let's do my distribution, and I'm done. So my final answer here would be 2 plus 2 log base 8 of x. And I'm good to go.
Okay.
Does that make sense?
Yeah.
Cool. Take a peek at 43 here. Did you say 43 or 53? You said 43, right?
I said 43, yeah.
43, perfect. So looking at this one, when I see ln, it's really just using log with a base of e. So we'll just keep that in mind. But when I have division, that's subtraction. So the first thing I'm going to do is I'm going to change this thing, which used to look like this, into something that looks like natural log of. Now here's my numerator thing. So 3y to the 4th minus natural log of x to the 3rd. From here, I want to continue separating this thing, so pulling it apart. On the left side here, I see multiplication. So I'm going to do my multiplication stuff right here, which is addition. So I'll get natural log of 3 plus my natural log of y to the 4th. Then I'm saying subtract off of this. Oops, keep that one blue. Subtract off my natural log. Whoops. X to the 3rd. So looking at this thing now, I want to identify my next step, which is going to come from whatever my exponents are. So I see that I have an exponent with this thing, and I have an exponent, whoops, we don't need fancy colors, with this thing. So this is pretty much done. That's going to stay natural log 3. This thing right here is going to get this exponent out in front. So y to the 4th is really like saying plus 4, now natural log of y. And then I'm going to say subtract. Now this 3 is going to come out in front, natural log of x. And we are good to go.
Okay.
Does that make sense?
Yeah.
Cool. Any questions on either of those?
No.
Perfect. So looking at 47 here, we're looking to condense the expression. So here we have natural log of 16 minus natural log of 4. This again has a base of e, and this has a base of e. Since these both have a base of e, I can take these things and say, this is going to be natural log of, and now I'll do 16 over 4. There's my subtraction quotient property. So looking at this now, I'm just going to simplify. I'm going to call this thing natural log of 4. And I'm done.
And that's all you do?
That's it.
Okay. Oh, wait. Also, on on chapter 7 test,
Mhm.
5C, I have no idea how to do it.
You want to talk about that one? Sure. We'll do that next.
Yeah, I've done it like 15 times, and I can't figure out how to get that.
I've
no
I've
worries.
looked it up too, and every math thing tells me the wrong answer.
No worries. We'll do it together. Are we good on the 8.5 questions though?
Yeah.
Perfect.
Yeah.
All right, so we're going to take a look at 55 and 71 as well here. So looking at 55 and 71, we're going to start with condensing our expression here. So when I see I have something which is raised, or excuse me, something with multiplication here, means I am raising this thing to an exponent. Before I do that, I want to take care of whatever addition, subtraction stuff is going on. So when I have a log subtract another log, and this is just natural log, so it's using base e here, I'm doing division of whatever the of thing is. So this is 3 divided by x. So I'm going to split this one up. I'm going to do the first part in orange right here. So this part right here is going to then become, oops, 3 times. So now this is going to be natural log of, and it's just going to be 3 over x. So I guess I'll change this to a bracket here. There we go. So that's what this orange thing became here as my first step. As my next step, I'm saying plus. So now I'm saying, okay, now I'm gonna have x over 9 for this second chunk. So here I'm going to just leave it as plus. Now here I have natural log of x over 9 here. So now as I am looking at this, I'm saying, okay, well, I want to take the two things here and I want to add them up. But first I'm going to take care of my exponent here. So this being out in front, the multiplication means that it's this thing raised to the third power. So I'm going to rewrite this orange thing as natural log of 3 over x to the third. And if you want to simplify this thing now, you can. If you want to simplify it later, that's fine as well. So I'm just going to rewrite this thing as natural log of 27 over x to the third. So again, whether you want to do this now or later doesn't really matter. I'm just doing it now so we can see the simplification. So now I'm going to just carry this thing down. So now I have plus natural log of x over 9. So now when I'm looking at these, again, I'm doing addition, so these things are being multiplied. So my final answer here is going to have natural log of, and I'm going to write these two things out with their respective colors. So we got 27 over x to the third times, and here I have x over 9. So the 27 and the 9 are going to cancel off. This is going to leave me with a 3 on top. And then I've got x to the third and x here. It's going to cancel off. It's going to leave me with x squared on the bottom. So my final answer here is going to be natural log of 3 over x squared. And I'm good to go. Any questions on this one? Perfect. So looking at our change of base formula here, we want to use our change of base to evaluate this thing. So when I see log base 9 of 5 over 16, this, oops, I'll use a different color here. This is going to be my numerator one. This is going to be my denominator one. And when I say that, I mean I can choose between whatever common base for both of them. There's two options that I would like to use. That's log, and I could also use natural log. So looking at these two things here, I'm just going to say the first one is going to be log over log, and this one is natural log over natural log. So again, using base 10 here versus my base e here. The top here is going to be my 5 over 16. My bottom down here is going to be 9. Same down here, and same up here. So if I wanted to evaluate this on a calculator, I would simply be doing one of these two options, and they will be equal to each other. So my change of base just says, okay, if I've got a base that's not going to be so nice for me here, what I can do is log of whatever base I want, as long as those two bases match. So here we have log base 10, my common logs, and then here we have our natural logs using base e. I could tell you an approximation for this thing as well. Just give me one sec to actually plug it in here. So let's see. Gives us approximately negative 0.5294. Again, just as an approximation to 4 decimal places. Any questions on this one? Perfect. We're going to start out with number 15 here from the 8.5 homework. So we're using the property of logarithms to evaluate the expression. So when I see natural log like this, what that means is I'm using log base e. So if you wanted to rewrite this thing, you could. Not necessary, but I'm going to rewrite this thing just so we see it. And I'll write it in two forms. One is I'll just write natural log with my base e shown, and I've got e to the negative 2 like this. That's one way of writing it. Again, unnecessary because we already know this is using base e, but whatever. If you want to write it as log base e to the negative 2, that's fine as well. The thing I'm trying to highlight here is that this has a base of e. So if I have log base e of e to the negative 2, you can basically just say this whole thing drops off, and all I'm left with is my negative 2. So that's the way that most people think about it. If that's not the way that you think about it, you could use the exponent rules as well. So my exponent rules for logarithms say if I have an exponent, I can take my exponent and put it out in front. So I could have this rewritten as negative 2 times, and then I'd say natural log of e. So natural log of e, again, is just going to be 1, right? E to the what is going to give me e to the first. So this thing was just negative 2 times 1, which is negative 2. Any questions on this one? Perfect. Looking at number 19 here, I see log of 1/10. Again, I don't see a base here, so this is a common log. This is using base 10. So if you want to write it as log base 10 of 1/10, you can. Again, not necessary, but if we want to, doesn't hurt. As I look at this thing, I'm saying, okay, 10 to the what equals 1/10. Well, 1/10 looks to me like I rewrote this thing as 10 to the negative 1. So again, same property as over here. If I have log base 10 of 10 to something, it's just going to equal whatever that something is. So in this case, it's negative 1. If I want to take my exponent and put it out in front, we can do that. Here I'd have negative 1 times log base 10 of 10. Log base 10 of 10 is 1. So here I get negative 1 times 1, which is negative 1. And we could have also evaluated this one using a calculator, although it's not what I would recommend initially. Any questions on this one? Perfect. Good to go.